talk about the geology of the moon from one of the most qualified people to do that, Professor Penny King.
Okay, so I'm going to tell you about rocks. And you might think rocks are a little bit boring.
No.
But no, they're not.
Who thinks rocks are boring?
No.
Oh.
I cannot see out.
Yeah. She's blinded by the light. You can do whatever you like.
That's right. So we have these great images of going to the moon. Now, Rod's image is really awesome, but we have images like these on the left, people working in a nice clean environment, having a lovely time, and Matt Damon, of course, in The Martian on the right. But the reality is actually quite messy. And the reason it's messy is because of geology.
Hooray!
Hooray! So on the left you can see Neil Armstrong, and he has left behind a mess of footprints. And on the right, Gene Cernan, who is an astronaut who didn't spend very much time on the moon, but you can tell he's really messy too. And that is because of geology. Right. So he's looking really kind of dirty, brown around the face. You can tell he's been playing in the mud. Or has he? He was actually playing out there in his suit, and when he took off his suit, all of the regolith or dust from the surface of the moon has dropped onto his face and his arms. Look at all that dirt on the right arm. Okay, so dust is the thing I'm going to talk about today. Not really geology because it's kind of ground up rocks. Not quite as good, but still fun. Okay, so what do the materials on the surface of the moon look like? And this is kind of surprising. When we went to the moon, we had no idea what we would find. And what we found is something that we've never seen on Earth. Okay, so you can see there are round things. Those are glass beads. So that rock has melted so much that it's turned into a tiny little bead of glass as it's flown through the air. There are little fragments of glass, broken up glass. There are minerals. There are little pieces of rock. It's angular. It's really fine and abrasive. And that stuff actually can cut your spacesuit, which John will tell us more about, I'm sure. There are also highly reactive things in that material. It's electrostatic, which means it gets everywhere, and you saw that on the astronaut. When you look close with an electron microscope, you see all kinds of really weird shapes, holes, and little iron spheres. So it's really weird stuff. We've never seen this on Earth. There's fragments that clump together. There's sharp minerals, and what we found when we went to the moon is we'd never seen anything like it. You can't make this on Earth very easily, and it's not anything like we've seen on Earth. And what that means is there's different processes that go on, and they're called impact gardening. Impact comes in, picks up the dirt and takes it elsewhere, and also space weathering. We also found some really strange volcanic rocks. So you've seen pictures of lava fountains on Earth. We found orange glass from lava fountains with so much titanium in them, we'd never seen anything like it before. And here are some that I actually analysed here. So that's about the size of a piece of hair. On the surface of those are the things I thought that Brad was going to tell us about, but he's gone. His title was about metals on the moon, and there's actually zinc that coats these spheres on the moon. And what we found is that zinc actually forms on those spheres as they go flying through the air and drop in temperature. It comes out of the gas and then adheres onto those little spheres. Really weird stuff. Stuff that we don't see on Earth. What can you do with this stuff? Well, you can measure the temperatures. That's what they did when they went with the Apollo missions, and here they are putting temperature probes into the surface. And you can see that as you go deeper, going up the picture, you get more and more warmth. And it's still pretty cold, so you can still keep ice there. And this ice that Brad's talking about is possibly buried in this regolith, which kind of acts like an esky and holds things at a constant temperature. Mars, completely different, but how much time do I have? Did I get Imogen's? 2.5 minutes. Oh my gosh. We're going to have to go super fast. So Mars different. It's got bright dust all in the northern hemispheres, lots of very fine material. It looks like this when you go with a rover and take a magnifying glass to it. And it's really a pest because the fine dust on the surface can bury things like rovers. And so here's the Spirit rover, its last picture, and where it got buried. The dust is also a problem when you try and land. And this is a picture on the left of the Curiosity rover's landing site from space. And you can see that there's a big black area. And that is actually where all the dust was blown away as the rover was landing. When that happened, all of the dust ended up landing on top of the rover. And so we've got all these rocks on top of the rover here. With Perseverance rover, they were a bit smarter and they filmed it as they came in. So that one landed this year, and here we see all the dust running away as the rover comes in. There's also a helicopter on Mars. So here's that helicopter about to take off, and that's all dust, that white stuff. So you can see the helicopter here in the real colours, and then they've made it look a bit different on the left so that you can see the dust. So dust, really important for things that you're putting on other planets. Next slide shows some of the movement from the atmosphere. Now the atmosphere of Mars is only about 7 millibars, depends where you are and what the season is, what the time of day is. But you can see on the left that's dust moving at the feet of the rover, and on the right, hopefully you can make out this dust devil as it moves across. That's super cool. When we first saw that, we were so excited. Dust, as I said, is really important. Sometimes dust covers the entire planet. So on the left, if you don't get dizzy, you can see Mars normally, and then Mars during a dust storm. Dust storms are really a pest. Here we are on the first day that the Curiosity rover landed, and we were waiting to take out the instruments to measure what was on the surface of Mars. And what do you think we measured first? Dust! Yay, dust! So here we are, we're at a sand dune looking at some dust, soil, and we scooped up the dust and we used that scoop to clean parts of the rover because it's abrasive, and so we took lots of scoops to try and clean the scoop parts. What we found was a spectrum like this. This is an X-ray spectrum, and you can use that to figure out the elements in the dust. So that's what we did. We know now that Martian dust might also, as well as being nasty, be toxic. It does have chlorates, perchlorates in it, some pretty nasty iron sulfates, other chloride minerals. So there's a lot of reasons not to like dust, or at least be aware of it. But I found there's a couple of really interesting people who have been taking simulant dust and turning it into parts. And so here on the left is a paper that they've taken the dust, simulant, and then made materials, mixed them together to build blocks. So these look like Lego, and they're making little Lego blocks out of the dust. Now, look at this. This is what they're using. Their Martian simulant doesn't look at all like what we saw the lunar materials look like. So it's a little bit hard to do this. There are other people who are 3D printing simulants and turning them into blocks. So that's pretty cool too. Okay, so what do we need when we go from Earth to the Moon to Mars? Well, we clearly need geologists. I'm going to put them first because of dust. And then we need a whole lot of other people too, because we need the engineers, we need the health people, we need a whole range of people to be involved, and that's why it's so good to be at Fill Up on Science with all these different people. So thanks.